Hello members, I hope we okay. This is Nanyonga Bridget from group 2. I'm going to present a topic that is force. That is question 1 in our group work. So I'm going to start by defining what a force is. Force, this is a pull or a push that is exerted on a body, or it is a pull or a push that changes a body's state of rest or uniform motion in a straight line. That is a brief introduction to the topic that I'm going to handle. So, force. If I have a bucket with me and I push that bucket, after pushing that bucket, it moves from the original position that it was in and it goes to a new position. So they have applied a force on that bucket. If I have a desk or a chair or a door and I push it or I pull it towards me, then I have exerted a force on that object that I have pulled towards me or I have pushed away from me. That means that I have applied a force. So generally a force is a push or a pull that changes a body's state of rest or uniform motion in a straight line, and in some cases it can even change the shape of the object. For example, if I have wet clay, if I have wet clay and I decide to mold it into another shape, that process when I'm molding that wet clay or clay, I am applying a force on it so that it can change its shape. So for that reason, therefore, I think I am free to define force as a pull or a push that changes a body's state of rest or uniform motion in a straight line or changes shape of an object or item. According to the research I made, a force is defined as a push or a pull exerted on an object that can change its state of motion or its shape. In simpler terms, whenever you push or pull something, you are applying a force. In physics, force is an interaction that causes an object to accelerate. When I'm pushing something away from me, it is going to change its speed. I can either make it move faster or I can make it move slower. By making sure that it moves faster, then I'm accelerating it and I'm changing the speed. So force can accelerate an object, or can cause it to stop moving, or it can cause it to slow down or to speed up or change the direction. And when we are calculating force or when we are measuring force, we measure it using newtons. That is the standard unit or the SI unit of measuring force. The standard unit used to measure force is the Newton, named after Sir Isaac Newton, who first described the laws of motion. And we have 3 laws of motion. The first law, which is the law of inertia. We also have the second law, which is conservation of linear momentum, and the third one, which is for every action there is an equal and opposite reaction. And in this question I'm going to focus a lot on that last one, the third one, which is for every action there is an equal and opposite reaction. That is, if I push a bucket, it is going to exert the same energy that I had used, or the same force that I had used when I am pushing it or pulling it. That is what that law means in simple terms. So I'm going to proceed. This question, that is number 1 that I'm doing or presenting, it has the types of forces. It requires me to give the examples of the forces The contact forces, which are those forces that require physical contact. The non-contact forces, which don't require physical contact. So those are the things that I'm going to talk about. I give the examples and the illustrations of those forces, those types of forces. Okay, let me take off from there. Starting with the contact forces. Contact forces are those forces that require physical contact to take place. Physical contact, it can be between the bodies to occur. For example, the frictional force or the friction force, which retards motion. It can also be tension force, which is that force that comes about due to pulling and putting an object under stress. That is, if I have a rope and I pull that rope, that means that I'm putting that rope under tension. I'm putting the rope under tension. That is another force, an example of other contact forces. And I also have a normal force. The normal force, that is the force that is exerted by a body that is resting on a horizontal surface. For example, a laptop computer. When it is seated there is a force that is holding it, refusing it to, or retarding it to fall and pass through that object that it is resting on. For example, the desk. A computer is able to rest on a desk due to the normal force. That one is a contact force because there have been physical contact between the computer laptop and the desk or the table. So that one is an example. So by definition, contact forces are forces that require two interacting objects to be in direct physical contact for the force to be exerted. These forces arise from the interaction at the boundary between two objects. Like other forces, these forces obey Newton's laws of motion, especially the third one. That means that when the object exerts a contact force on the second object, that second object is going to exert the same force towards the first object that applied the force first. That means it is obeying Newton's third law. And Newton's third law is that it states that for every action there is an equal but opposite reaction. So let me proceed and give some examples. Example number 1, we have normal force. The normal force is defined as the support force exerted by a surface on an object that is in contact with it. Its name comes from the fact that it always acts in a direction that is perpendicular or normal to the surface of contact. That is what I was saying, that if anything is resting, for example, me, when I'm seated here on this desk or a chair or a mat, when I'm seated there, motionless, doing nothing. Okay, let me give another example of resting. I think that one is more suitable. When I'm resting, sleeping, that force that is acting between me and that mat, or me and the bed, or me and the chair or desk on which I'm sleeping, it is the normal force. It refuses me or prevents me from passing through that surface and falling down. That is the normal force. A common example is the normal force. The normal force is a force that supports the body and the surface. And its fundamental role is to prevent the object from penetrating or falling through the surface it is resting on. In many situations, such as an object resting on a flat horizontal surface, the magnitude of the normal force is exactly equal and opposite to the component of the object's weight that is pressing into the surface. I think there I am clear. I have explained it very clearly. An example, I've given many examples, but there is a book resting on a horizontal surface, that is a desk. Let me take that one. Another one, another crucial example, it is the friction force. Friction force is the force that opposes relative motion between two bodies or two moving surfaces, two or more. Not necessarily two forces, but two or more forces. Now, let me take an example of friction force. When I'm rubbing a blackboard, it is friction force that enables me to rub off that chalk from the chalkboard or the blackboard. When I am lighting a matchstick, it is friction force that enables me to light that matchstick using the matchbox. If friction wasn't there, there wouldn't be light energy. So, friction force is a contact force that fundamentally opposes the relative motion or attempted motion between two surfaces that are touching. It acts parallel to the contact surface and in the direction opposite to the movement. That is, it retards motion. It retards movement of two objects. Take an example, when you are moving using some slippers. There are some slippers that are very slippery for us ladies. There are some slippers that are very slippery, and you are walking on a slanting surface. There, the friction force is somehow small. It is little, the friction force there. So you are literally going to fall. You're going to fall because the shoes are sliding, there is no friction force. But if you are wearing some shoes that whose sole is not very slippery, you won't fall from that slanting surface, because frictional force will be retarding your motion and movement. So friction force arises from the microscopic irregularities and adhesive forces between two surfaces pressed together. When one object attempts to slide over the other, these microscopic bumps and attractive forces resist the movement. I think there I am very clear. I'm moving on to the next one. The next contact force. It is the tension force, which is the pulling force acting between two bodies. When I have a rope pulling it, it can be a wire, it can be a wire, and something that can be elastic. When I'm pulling whatever I have, there I'm exerting tensional force. It can be a string, it can be a cable, it can be a chain, it can be a wire. When I'm pulling it, I'm exerting tensional forces. So tension force always acts away from the object it is pulling and along the line of the connector, assuming the rope or cable is massless and inextensible. That is, it is not elastic like a piece of paper or a stick. It is not elastic, it cannot stretch. What if it is like that? A common simplification in introductory physics: the tension is uniform and has the same magnitude throughout the entire length of the cable. Essentially, tension is the force required to hold the rope or cable together, preventing it from snapping when the object pulls on its ends. A classic example of tension force involves a chandelier lying or hanging motionless from the ceiling by a chain or a cable. Those have been the contact forces. So now moving on to the non-contact forces, of which non-contact forces are these forces that don't require physical contact. And I have some examples. One, I have gravitational force. From there, I have the electrostatic force, magnetic forces, all those ones. So what is gravitational force? Gravitational force, it is a fundamental non-contact force that exists as an attractive force between any two objects, pulling them towards the center of the earth. If I throw a ball upwards, the ball will come back downwards. So that force that pulls the ball to come back downwards, it is the gravitational force, or the force due to gravity. That is it. I also have another one. It is the magnetic force, which is the attractive or repulsive force exerted by magnets on each other or on susceptible materials like iron. Magnets, we all learned about magnets. North Pole, South Pole, they are going to attract each other. And that area where they are attracting each other from, it is a magnetic field. So they are either going to repel each other or they are going to attract each other. They attract each other when they are of opposite poles. For example, North Pole and South Pole. If it is North Pole, they are going to repel. South Pole, they are going to repel. So the force that causes those different opposite poles to attract each other, it is the magnetic force. And the force that causes repulsion, it is also the magnetic force. Then I have the electrostatic forces, and these ones mainly occur due to charges. If I have a ruler and I rub it in my hair, and then I get a piece of paper, I put it on the desk, I get my ruler that I have rubbed properly on the head or the hair, I bring it closer to this piece of paper. The paper is going to be attracted to the ruler. Why? Because the ruler has become charged. So those are some examples of the non-contact forces. The force due to gravity, magnetic force, electrostatic force. I decided to use those examples in my presentation. So I hope everyone finds this of use, and I hope you like it. Thank you so much for watching.